So I'm Paul. This is my channel, so you are welcome. Now in this channel you are going to see some key facts in sciences as well as engineering, some videos in physics, in chemistry, in mathematics that will boost your knowledge. So but today I'm going to talk about wave duality, and I'm really going to look at the Heisenberg uncertainty principle. So that is going to be the uncertainty principle. Alright, so now the uncertainty principle was used, or is normally used, to look at the behavior of matter, because matter can behave like a wave and matter can also behave like a particle. Now it is known that due to experiment that the experiment that matter behaves like a wave cannot be the same experiment that will be used to know that matter behaves like a particle. Why? Heisenberg discovers that if such happens, then it is going to be mute for the two of them. That is why it says that if an experiment is used to know that matter behaves like a particle, then matter behaving like a wave is going to be mute in that same experiment. That means it is not going to take place. Now, if an experiment shows that matter is a particle, then matter being a wave is going to be mute in that particular experiment. So what do we now discover as a principle? This principle shows that neither the position nor the momentum of a particle can be determined simultaneously with great precision. Neither the momentum or the position of a particle can be determined simultaneously with what? Great precision. That is the principle. Now, this principle can be shown mathematically in two different ways, and it is very, very important to us. That means that if there is, for example, a change in position of matter or a change in position of any substance, now that is going to be through the x coordinate. So it's going to be like this, a change in position. And also, if we have, let's say, a change in momentum of that particle still to the x coordinate, that is going to be times we have the change in momentum. So this is going to be greater than or equal to h over 2 pi, greater than or less or equal to h over 2 pi. Now 2 pi here is equal to 360 degrees. Let's see how that works. If we say 2 pi radius, 2 pi as a radian, if we are changing from radian to degrees Celsius, we multiply it by, we have 180 over pi. So in that case, pi is going to cancel pi. 2 times 180 will now give us 360 degrees. The same thing goes with pi. We have pi radian. If you are changing it to degree, that is going to be pi times 180 over pi. Pi cancels pi, we are left with 180 degrees. So that means that pi radian in degree is 180 degrees. 2 pi radian is going to give us 360 degrees, and so on. So in this case here, we have the first formula here that shows the uncertainty principle. We are going to look at another formula. This formula links energy with time. That means the energy in the uncertainty, that is going to be the change in E times the change in the time. We say greater than or equal to h over 2 pi. So we have another one here. In these two here, we know that change in x represents the uncertainty in the position. And we have here change in p here as uncertainty in the momentum. We have here change in E uncertainty in the energy. And then we have also change in T as uncertainty in the time. We have another one left, and that is h. So this h refers to the Planck constant. So it refers to the Planck's constant. And then if you have these two formulas here, you can now work or deal with some mathematical problems with the uncertainty principle. So this will help you and guide you. But apart from using this greater than or equal to, we can decide to remove this greater than or equal to here to have something like this. Change in x times change in p, we have h over 2 pi. Since it is greater than or equal to, it means that it can at the same time be equal. So in that case, we can as well say that change in E times change in T equal to h over 2 pi. You have to remember that h here represents the Planck's constant. And we have over 2 pi here. So these two formulas here are very, very significant when we are dealing with the Heisenberg uncertainty principle, which says that neither the position nor the momentum of a particle can be determined simultaneously with great precision. That means the position of a particle and the momentum cannot be determined at the same time in that same experiment. Rather, they can be determined in different experiments and in different times. That is what the uncertainty principle tells us about matter. Matter behaving like a wave and matter behaving like a particle. So in our next video, we'll be discussing some calculations that deals with this uncertainty principle. So bye for now.